Welcome. In this particular video, we'll be looking at the law of science and application. Let's go ahead and read the scenario. A ship is sailing due east. At a certain point, the captain observes a lighthouse at an angle of 31 degrees clockwise from north. After the ship sails 29 kilometers farther, the same lighthouse is at an angle of 315 degrees clockwise from north. Draw a diagram below to illustrate the situation. Let A be the point where the first lighthouse observation is made, and C be the location of the lighthouse. Make sure you include all the relevant information in your diagram. So let's go ahead and extract the information here. First, we know that the ship is sailing due east, okay? So we know this for sure. Then we know that at a certain point the captain observed a lighthouse at an angle of 31 clockwise from north. Okay, so an angle of 31 clockwise from north. And after the ship sails 29 kilometers further, okay, the same lighthouse is at an angle of 315 degrees clockwise from north. Okay, so that's the important information here. Now, we're being asked to draw the diagram. So let's go ahead and get started with the actual scenario here. Okay, so we know for sure that we are going towards east, okay? Based on the first sentence, we're going due east. Now, let's say we have a specific lighthouse here, okay? Somewhere along the pathway, the captain turns around and looks at this particular lighthouse. That particular lighthouse, okay, would have an angle of 31 degrees clockwise from north. So let's say here's your north. Let's pretend this is your north. And we know that it's going to be the angle from north, it's 31 degrees. So we know that this is going to be 31 degrees. Now, this is your north and this is your east, okay? So we know that they make a 90-degree angle, okay, a right angle. Let me put that there in the diagram. Now, since this is a 90-degree angle, okay, this two angles will form another 90-degree angle, another right angle. That makes them complementary. So we can figure out what the measure of this angle here is by subtracting 90 minus 31 degrees. So we do that and we get that this particular angle is 59 degrees. Now they kept going for 29 more kilometers, okay? So they kept going for 29 kilometers in their pathway towards the east. And then after 29 kilometers, they saw the same lighthouse at an angle of 315 degrees clockwise from north. Okay, so there's another observation, okay, done somewhere along the pathway here after 29 kilometers. Now, also based on this information, they tell us the following. They said, okay, the angle was 315 degrees clockwise from north. So we can already picture what's going on here, okay? So this particular angle from north, let's say here's your north. From here all the way to here, we know that that angle is 315 degrees. Now, if we were to complete the whole loop, you know that that measure will be 360. So that makes this particular angle here 360 minus 315 when it comes to its measure, okay? So that's a 45-degree angle. One more time, making use of the fact that north and east make a 90-degree angle, we understand that these two angles are complementary. So you would just subtract 90 minus 45 degrees to get the measure of this particular angle, and that makes it a 45-degree angle as well. Now, with that said, we can figure out the third angle. How do we do that? Well, we know that the sum of interior angles in a triangle in Euclidean geometry is always 180 degrees. So we're going to add these two measures and subtract them from 180 degrees, and that will make this particular angle to be 76 degrees. So that gives you your diagram. Now, they actually tell us to label them the following way. So A is a point where the first lighthouse observation is made. So here's A. Then they also tell you, okay, C is the location of the lighthouse. So here's your C. And the remaining vertex will be label B. Okay, so you can use the standard notation for labeling this type of triangles. Now, if you move on to part B, it's asking us to use the law of sines to find the distance between the lighthouse and the ship at the time of the first observation. So in other words, okay, if we were to go back, they want us to figure out this particular distance. Now, it would be crucial for us to remember that we could actually label the sites based on the angles across from them. Okay, so since we're going to use the law of sines, we're going to say, well, the side across from angle A, in this particular case, this side, it's the side that will have a length of lowercase a. Then the angle across from angle B will be the side that has a length of measure B units. And then the side across from angle A would be the side that has a length of C units. In this case, units are kilometers. So our goal, let's see what's our goal in this particular scenario here in part B. They want us to find the distance between the lighthouse and the ship at the time of the first observation. In other words, they want us to figure out what the value for B is. So our goal is to figure out the unknown B. So using the law of sines, we know that sine of A over A is the same as sine of B over B, which is the same as sine of C over C. Let's go ahead and substitute information based on our diagram. So we know that sine of angle A would be sine of 59 degrees over A, which we don't know what it is yet, okay, is equal to sine of B. So sine of B is equivalent to sine of 45 degrees over B. We don't know what B is yet. And this is equal to sine of C. So we have sine of C. C is 76 degrees, so we have this being sine of 76 degrees all over C, which in this case happens to be 29 kilometers. Now, since our goal is to figure out what the value for B is, we're going to be utilizing this particular ratio. And let's use the one that already has the relevant information, all of the numerical information, in this case this one, so we don't have to deal with another unknown yet. So we're going to set up our proportion as follows. This implies that sine of 45 degrees over B is equal to sine of 76 degrees over 29. Now we can just do cross multiplication. Let me use a different color so I can show you step by step. So here we're going to cross multiply sine of 45 degrees times 29. So this gives us the equivalent statement. 29 sine of 45 degrees is equal to, okay, we cross multiply the other ones. So that gives us B times sine of 50 or sine of 76 degrees. So B times sine of 76 degrees. Now, to isolate the unknown here, let's divide both sides by sine of 76 degrees. Now, this implies then that B, it's simply, since this cross out, equal to 29 sine of 45 degrees divided by sine of 76 degrees. And if you enter this in your calculator, okay, you have 29 sine of 45 degrees divided by sine of 76 degrees. That will give you approximately 21.13 kilometers. Therefore, the distance between the lighthouse and the ship at the time of the first observation is 21.13 kilometers. And we can write that down. So the distance between the lighthouse and the ship at the time of the first observation is about 21.13 kilometers. Okay. Now with that said, we can move on to part C. Okay, part C states the following. Use the law of science to find the distance between the lighthouse and the ship at the time of the second observation. So we go back to our diagram here, up here. We are now going to be looking for the value for A. The nice thing though is that in part B we already have the setup. Okay, so now we're going to be looking for A. Therefore, we can actually use this particular ratio along with the ratio involving angle and side C. Okay, so that's what we're going to be using to set up our proportion here. So for part C, our goal is to figure out the value for A. So we can say, well, based on this given information, we have sine of 59 degrees over A is equal to sine of 76 degrees over 29. And again, we proceed normally. We're going to cross multiply, so this implies that we have 29 times sine of 59 degrees is equal to A times of sine of 76 degrees. Now our goal is to get the A by itself, so what we're going to do, we're going to isolate it. We're going to divide by sine of 76 degrees on both sides of the equation. And by doing so, we get the following value for A. This implies that A, after you cancel this one, is equal to 29 times sine of 59 degrees divided by sine of 76 degrees. Okay? If you were to enter this into the calculator, you get an approximate value of 26.62 kilometers. So one can conclude the following. Therefore, the distance between the lighthouse and the ship at the time of the second observation is about 26.62 kilometers. Okay. So notice here in this particular application, we were able to sketch the diagram with the relevant information, and we were able to find the distances between the lighthouse and the ship, first at the first observation, and secondly, based on the second observation. Okay. I hope you have enjoyed this particular video. I want to wish you a wonderful day, and I hope to see you soon. Have a wonderful day.